Thank you all for coming out today. I didn't realize this conference was on a weekend when I signed up for it, so I really appreciate you all coming out instead of getting a day off of work. My name is Tim. You may be familiar with some of my previous projects, Kubernetes. If so, I apologize in advance. Given my background, I tend to look at this agentic AI problem as an infrastructure problem. I see it from the bottom up. The customers that I talk with come to me and they say, we've got these agents, and Goja, like your explanations of the breadth of agents is exactly on point. There's a million kinds of agents, but they all come to us with similar problems, saying we need to run them, we need to run a lot of them, we need the efficiencies that we're not getting. Agentic workloads are very different from traditional applications, which is really, it's caused people to ask whether Kubernetes is the right platform to run these things. It warms my heart to see Kubernetes mentioned on other people's slides, but I think it's a fair question. And so given this audience, I'm not going to go too deeply into how agents are different. I'll touch on it just a little bit. I apologize for racing through this material. I'm happy to do it again in the halls or talk whenever, after we're here for the next 2 days. So let's look at a couple of the things that make agents interesting. Agents are very bursty. They tend to work in very short spurts and then go idle for a long time, minutes, hours, even days, weeks at a time. This means a lot of idle resources if you approach it naively. Agent workloads, generally untrusted. I think it's pretty well understood at this point. Because of that, they have to run in sandboxes, and we're always looking at new kinds of sandboxing. And they have to run single tenant, because you can't share a sandbox. That would kind of defeat the purpose. That means we miss out on a ton of opportunities for optimizations, specifically the amortization of overheads. And lastly, they tend to have humans in the loop, which makes them very sensitive to the perceived latency of these systems. Taken together, this kind of makes it problematic to run them on Kubernetes. Kubernetes was built for things that run for a long time and tend to be scale out, horizontally scalable, and you can amortize your costs. So before jumping to a solution, I'm going to touch on the state of the art, what we've observed at Google and in the Kubernetes world of how people tend to run agents on Kubernetes. And there's really only two patterns with a few variations. So first is the obvious way. So Kubernetes has this idea of a runtime class, which lets you define a kind of sandbox. And the default runtime class is a Docker-style container, an OCI container. But we also have runtime classes for gvisor and for micro VMs, and it is an extension point for Kubernetes, so people can do interesting research around that. Some event causes the need for a new instance of an agent. So for example, a user starts a chat session. This obviously requires instantiating their agent, a special dedicated single tenant instance just for them, and each of those runs inside of an agent, a sandbox pod. Now, there's some cost. Starting up a pod on Kubernetes is not the thing that Kubernetes does the fastest. It's not optimized for that. It's not built for that. It's fast, seconds usually, but that's not fast enough. And so depending on what that agent does at startup, it could take a long time. And we've seen agents that load runtime environments that can take 10 or 15 seconds or more. Browsers, like all sorts of things. Eventually, that pod becomes ready and the user can chat with it, and they send their message to the pod and it comes back, and one turn is done, right? And now what? So because pod startup isn't free, what people tend to do is they wait for another event. And how long should they wait? Well, that really depends on what your agent is doing and what the startup cost was, and you have to do some math, and it's different for everybody. We've seen this range from tens of seconds at the low end to tens of minutes at the high end. And during those tens of minutes, your agent is sitting there consuming resources that can't be used by anybody else. Eventually, and of course this might happen multiple times, right? At 9 minutes and 59 seconds, the next turn might happen, and you start the whole process over again. So eventually you get a timeout and you're deemed idle, and either you're discarded entirely or we save your state somehow and then we terminate the pod, right? This is the standard Kubernetes lifecycle. Now, keep in mind this is happening for every instance of every agent, for every user that is happening on your systems. There are tricks we can play with warm pools, and there's tricks we can play with suspend and resume. But Kubernetes doesn't support those things natively, and so you're kind of working around the system, and it's difficult to justify at this scale. The second approach is for people to build a DIY system on top of Kubernetes. Basically, this looks like a giant workload per machine. Inside that workload is a manager application. A bespoke control plane is responsible for scheduling things into that mega sandbox. The manager manages the lifecycle. Everything's opaque. Kubernetes doesn't know what it's doing. You end up reinventing large parts of Kubernetes. It's fairly complicated to build. It can be very efficient. It's difficult to operate for smaller companies, especially startups. Now, I'm a huge fan of open source. Maybe you can tell because I work in Kubernetes for the last 12 years. I have a deeply held belief that when it comes to infrastructure, open always wins. And so earlier this year, we set out to build something new that takes the best parts of both of these models, leverages Kubernetes where it can, because almost everybody has some Kubernetes in their fleet, and builds new components where we have to. Now, I'm not going to pretend that we've discovered anything new. We have not done any earth-shaking research here. What we've done is take some of the best ideas from all of our customers and our users and tried to glue them together into a way that everybody can use. In the same way that you put Kubernetes up on the slides as the middle box, I would like to fill in the right-hand second box for you. So Agent Substrate, and thank you for mentioning it, is a project that we began earlier this year. And have open sourced it. You can go to this URL, it'll take you to our GitHub. It's from a very high level, the model is pretty straightforward. We don't want idle resources. We want to use suspend and resume and cloud storage to multiplex agents onto pre-warmed runners and aggressively suspend and resume agents to take those 10 seconds to 10 minutes of idle and drive it down to a single second or even less. So let's talk about the goals. We're Google, so we tend to see things from the large scale point of view. We're shooting for very large deployments. We're looking at billions of sessions under management. We're looking at tens of thousands of activations per second, and we're looking at driving the wake-up time down into the low 3-digit milliseconds. Quickly, I'll introduce some terms. We have an actor, which is sort of a stand-in term for agent or sandbox or thing that acts like an agent. We have an actor template. If an actor is a cookie, the actor template is the cookie cutter. It includes details like what kind of sandbox tech, is it a gvisor or a micro VM? Notably, there can be many different templates inside of a single substrate. We have a worker, which is usually a pod running in a Kubernetes cluster. This is the thing that actually consumes resources. It waits for an assignment of an actor, and then it runs that actor. It can run many of them in serial, and a cluster can have many workers. And then 8lit is sort of our per node manager for all of the workers on that node. We need this for reasons around networking. And then lastly, 8net is our enlightened proxy, which will trigger wake-ups on receipt of traffic. Let's see how those fit together. Start with a Kubernetes cluster. Any modern cluster should work. We support running in kind, so you can run it on your laptop. The cluster admin deploys an instance of Agent Substrate, which includes an API server and storage layer, a controller which synchronizes data in and out of Kubernetes, one or more worker pools which create deployments, which create pods to run your workloads in, 8lits to manage all those workers, the 8net proxy which knows how to pass traffic from the outside world to the inside world, and then the Substrate admin can create one or more actor templates. And the controller sees these and does some prep work. Specifically, it spins the actor template up, takes a snapshot of it, we call it the golden snapshot, stores that somewhere so we can use it later. Now, shifting view quickly to the Substrate layer, which sits on top of all this, I'll warn you, some of this is aspirational, we're still working on it. We have our API server, router, and workers. Someone, a higher order system, creates an actor from that template. For example, the same chat agent. The chat app does whatever front-end work it needs to do, authorize it, whatever, and then it creates an actor. Note, creating an actor doesn't run the actor. In this hypothetical app, the user talks first. So the user sends a prompt, which is received and routed to the 8net proxy. It wakes up the actor, assigns it to a worker by sending a message through the router, and then talks to the worker on a private connection. Since this is a new actor, it wakes it up from the golden snapshot. The 8net proxy forwards the message on to the now running actor. And the cool part is this happens in a couple hundred milliseconds, and we're working on that optimization still. As soon as that turn is done, the actor is probably idle, so we can tell it to go back to sleep. and suspend it. We call it pause. It can be paused, take the snapshot, and shuffle the data off, and now the worker is unassigned. It's available for use by another actor. All of that can happen as fast as your API operation or your agent transaction happen. Again, if another prompt comes in, we'll start the cycle again. And eventually, no more messages are received, and we will shuffle the data off to cloud storage, and it'll go to sleep for the night. Looking at the whole thing from the highest level, a Kubernetes cluster can be a one-node cluster on your laptop, or it can be 200,000 nodes in the cloud. Each of those nodes can run multiple workers. Each of those agents are idle 99.999% of the time, so you can do the math and see we're driving up to those billions of numbers. Agent Substrate is an open source project. It is still pre-production grade, but we're working really hard to get it out into a workable state by the end of this fall. And come take a look at it if you're interested in it. Take a look at what we've done. Bring us your feedback. The most useful thing that we can get from people is experience and requirements and context about what you're doing with agents. We'd love to hear from you. Thank you, everybody.